Today we'll be talking about exoplanets, or extrasolar planets if you want to get technical. An exoplanet is a planet outside our solar system. But before that, let's go over what defines a planet. To be considered a planet, an object in space must meet three criteria. 1. It has to orbit a star. 2. It has to be massive enough to be round. And 3. It has to have cleared its orbit of small rocky or icy formations called planetesimals. While our formerly ninth planet met the first two qualifications, it fell short on the third. Sorry, Pluto.
Today we'll be discussing 6 different methods to discovering exoplanets and going into depth with them. The methods do include direct detection, the Doppler wobble, gravitational microlensing, the astrometric wobble, pulsar timing, and planetary transit.
Planets are extremely faint light sources compared to stars, and what light comes from them tends to be lost in the glare from their parent star, making them hard to detect. If the planet is far enough away from its star, its thermal emission can be observed using direct detection.
The Doppler method. As a star moves alternately toward and away from us around the center of mass, we can detect its motion by observing alternating Doppler shifts in the star's spectrum, a blue shift as the star approaches, and a red shift as it recedes.
More than a dozen planets have been detected by using microlensing, which is a type of gravitational lensing in which the light of the star is temporarily magnified as other stars pass in front of it and bends its light.
The astrometric wobble uses very precise measurements of stellar positions in the sky to look for the slight motion caused by orbiting planets. If a star wobbles gradually around its average position, we must be observing the influence of unseen planets.
A pulsar is a rotating neutron star that emits radio waves extremely regularly as they rotate. When the radio wave is interrupted, it can be an indicator that a planet is orbiting the neutron star.
The transit method searches for transits and eclipses by carefully monitoring a star's brightness over an extended period of time. Because most stars exhibit intrinsic variations in brightness, we can be confident that we have detected a planet only if we observe the dips in brightness to repeat with a regular period, indicating that planet is passing in front of the star at the same time in each orbit.
Okay, so I'm having us start as close as I can get to Kearney's latitude and longitude measurements. And now we're gonna go visit one of the weirdest exoplanets. This one is called Kepler 7b. It fits into the hot Jupiter category. Its mass is about 0.43 times the mass of Jupiter's, while the radius is equal to that of almost 1.5 Jupiters. It's one of the least dense exoplanets found so far, and it's actually said to be as dense as a chunk of styrofoam and could even float on water. And its habitable zone is depicted here by the bluish halo, and it depicts, or it can show where liquid water could exist on a planet's surface, which of course everyone knows is kind of necessary for life to be able to produce. Okay, next we'll be visiting one of the largest exoplanets. This one is called Kepler 47c, and it's a gas giant discovered in 2012. Its mass is 28 times the mass of Jupiter, while the radius is only that of about 4/10 of Jupiter. They discovered this exoplanet by using planetary transit. Fun fact, if one were to travel to Kepler 47c by car at the speed of 60 miles per hour, it would take about 54 billion years, while at the speed of light, it would take almost 5,000 years. Alright, so the last exoplanet we'll be visiting today is one of the smaller planets. Its name is Kepler 407b, and it is a terrestrial planet just like Earth. And it was actually found just this year. Its mass is 6/100th that of Earth's, while its radius is equal to 0.095 Jupiters. It was also found by planetary transit method, just like the last planet. In this view, you can view it in its own planetary system. And in this view, you can compare it to our solar system. Notice how when I zoom in, Kepler 407b is closer to its star than the planets in our solar system are to the Sun.
Oh. Sorry, there was like a little hair. That's why I was like, I'm just gonna blow that right off.
Well, shit. Now you just gotta flip the table, storm off.
Well, we can keep going. I'll just crop that down at the end, you know. I'm sorry.
Ruining everything. It's all good.
The sun, it was the waves.
Yes.
Okay,
Yes,
so
it was.
we can keep going now.
There's wind in space. It's proved. Do I go crazy for a second?
If you want, however you want.
There you go.
Okay.
You are the